Good day. The title of my paper is Experimental Scientific Method, Advancing Science Education Through Galileo's Mathematical Equations for his studies on gravity and motion. I am Azalea Gallano, a student in the University of the Philippines Open University, Philippines. Through expository essay, the astronomical discoveries, heavenly motions, projectile motion, and laws of falling bodies introduced by Galileo through his mathematical experiments are expounded in this paper. Inquiry, critical, and analytical thinking are the required skills of the 21st century. One great avenue to stimulate the application and thereby develop these 21st century skills is through the use of scientific method. When regarded in its truest sense, the scientific method is a complex process which does not strictly follow a linear set of procedures. A carefully planned, administered, and validated experiment is irrefutable and worthy of consideration, whether it counters other beliefs or even the widely recognized discoveries. In relation to this, scientific method requires creative and critical thinking to conduct a complex experiment where careful and repeated observations of a phenomenon are a primary ingredient. The wide range of remarkable inventions and discoveries of Galileo, some of which he discovered through serendipity, had proven the worth of the scientific method which he pioneered through the use of a mathematical experiment. Galileo Galilei was born on February 15, 1564 in Pisa, Tuscany, Italy. In 1581, he changed his career from medicine to math and philosophy. In 1589, he established theorems on centers of gravity, and he began his interest in science of motion. He discovered that the speed of a falling object is not proportional to its weight. He published this through his paper on motion, which contradicted the Aristotelian philosophy on geocentric belief, and it ended his career in the University of Pisa. In 1609, his focus transferred to heavenly bodies with the use of his telescope, and he disproved the geocentric belief, and he was converted to the heliocentric orientation. In 1632, Galileo published his satirical manuscript about his discoveries using mathematical experiments as the scientific method. In 1633, while under house arrest until his death in 1642, he summarized his math experiments on motion, especially on law of falling bodies and parabolic path of projectiles. All works of Galileo contributed to the advancement of science of motion: swinging pendulum, falling objects, projectiles, heavenly bodies. In 1632, Galileo published his Dialogue Concerning the Two World Systems, a satirical presentation of two philosophies which shaped the science education as it shifted from the Aristotelian geocentric belief to the Copernican heliocentric belief through discussion among Salviati, Sagredo, and Simplicio. Salviati characterizes Galileo or the heliocentric philosophy. Simplicio characterizes the geocentric belief, while Sagredo is a layman. The weight of the findings of Galileo's experiments put his reputation at stake. He contradicted not only Aristotle's beliefs, but more so the Catholic Church beliefs on motions of heavenly bodies where the earth is the center of the universe and the sun and moon moving around it. The Catholic Church misinterpreted Joshua chapter 10 verse 12. It says, "Sun, stand thou still upon Gibeon, and thou moon in the valley of Ajalon. And the sun stood still, and the moon stayed, until the people had avenged themselves upon their enemies." And Ecclesiastes chapter 1 verse 5, which says, "The sun also ariseth, and the sun goeth down, and hasteth to his place where he arose." It would be easier for Israelites that time to understand that it was God who delivered them in a battle against Amorites if it would be directly pronounced that the sun and moon stayed. It does not necessarily mean that these bodies are revolving around the earth in ordinary days. In like manner, it does not literally mean that the sun rises and sets. Part of Galileo's study on motions tells us that the earth rotates around its axis from west to east, and so it just seems that the sun rises in the east and sets in the west. One fact stands still, that the Bible is written for human beings according to their level of understanding. The key features of the scientific method of Galileo are documentation of observation of objects at different times, repeated experiments through measurement of dependent variables like distance and period of pendulum, analysis of the relationships between the dependent and independent variables like time and length of pendulum respectively, and recorded observations, the synthesis of which he published in Starry Messenger. Galileo compared the distance traveled by rolling bronze balls in an inclined plane with the time it took for the pendulum to oscillate, called the period of pendulum. He compared the relationships between time and distance by continuously increasing the length of the pendulum and found that the time elapsed is proportional to the distance traveled. He was able to conclude that given constant speed and uniform acceleration, the velocity of a moving object is proportional to the time elapsed until the object reaches the ground. He was able to establish the law of falling bodies through the equation V equals g times t, where v is the velocity, g is the acceleration due to gravity, and t is the time elapsed. Moreover, Galileo was able to establish that the distance traveled by the falling object is proportional to the square of time elapsed through the equation d equals 1/2 times gt squared, where d is the distance traveled in meters, g is the acceleration due to gravity, and t is the time elapsed in seconds. In addition, Galileo was able to describe the period of a pendulum in terms of mathematics. He did this by comparing the movement of the swinging lamp in a cathedral in Pisa and his pulse rate. He was able to find that regardless of the mass of the object suspended in a pendulum, the period of its oscillation is defined by the equation t equals 2 pi times the square root of L over G, where t is the period of the pendulum, L is the length of the pendulum, and G is the acceleration due to gravity. From this mathematical law, Galileo deduced that the period t can be made longer by increasing the length L. This is expressed through the explanation of Salviati in the fourth day of Galileo's Tunia's New Sciences, where he likened the relationship between the length of the pendulum and its period to the motions of the Earth's moon to the moons of Jupiter. According to him, moons that move in the larger circles take more time in passing through them. Hence, the period of the pendulum is directly proportional to the square root of the length of the pendulum. Galileo's studies extended to projectile motion. He rolled inked bronze balls across a horizontal table and off the edge as well. He varied the horizontal velocity and the vertical height of the table. He was able to discover that projectiles observe a parabolic trajectory. Here are the conclusions. First, the experimental scientific method was proven to be an effective way of understanding the laws of nature, especially through the use of the language of mathematics. Galileo had proven that mathematics is the language of the universe and that the scientific method should make use of it through empirical experiment. By saying so, scientific method should allow replication where experiment may be conducted repeatedly, which may lead to either discovery, contradiction, or improvement of a theory or a mathematical equation. Thus, the scientific method in the truest sense supports that science is continuously changing in pursuit of the knowledge of the truth. Second, proving the heliocentric belief in contrast with the geocentric idea and the discovery of concepts behind the science of motion are great contributions of Galileo to the advancement of science using the experimental scientific method. Through this, Galileo had proven that science does not contradict the Bible. His unwavering faith in God through the wonderful creation his telescope revealed had empowered him to go further with more discoveries, knowing that he was the same God who inspired the writing of the Holy Scriptures. In 1992, the Catholic Church has reinvestigated the heresy case which Galileo was accused of and made a public apology. Science will not deny the Bible. True science is first and foremost biblical. And third, the milestones in science which the human race has achieved through Galileo are truly meaningful, paving way for more advances. The scientific method that is grounded on trial and error or experimental method should be inculcated in science and mathematics education, like writing a journal and derivation of formulas. It is indispensable that they learn through this process that a scientific concept is developed from a series of trial and error endeavors. Truly, history and philosophy of science lessons in both subjects should be part of the curriculum and lesson plans so that conceptual understanding will be honed. Thank you for listening. I am Azalea Gallano, and you may contact me through aagallano@up.edu.ph.